Again, many thanks for the invitation to speak at this global symposium. I'm going to talk about the good for human society and the Earth we can do using artificial intelligence and digital technologies, just like the other speakers in the symposium. Particularly, I'm going to be talking about intelligent decarbonization. The idea here is to utilize artificial intelligence and cyber-physical systems to decarbonize the economy and thereby help achieve climate mitigation targets. Let's dive into it. Why are these two critically important topics? Because they're both existential risks. And here you can see what I believe is the best visualization of the climate change issues. You can see here years from the mid-19th century to 21st century, years with below average global temperature represented in blue, while red years represent years in which the average temperature was higher. And as you can see from this, the last years, the Earth is getting hotter and hotter, and obviously this has impacts on human habitat, animal habitat, as food supply and water supply. So we really have to sort the climate change issue in order to ensure humanity's survival, and that's why it's an existential risk. On the other hand, we have superintelligence, and obviously this community, you have all read the book Superintelligence by the Oxford philosopher Nick Bostrom. What do we do when a superintelligence runs out of course, when it's getting malignant and actually wants to interfere with human survival? This is also an existential risk, so we're talking about two very critical topics for humanity. However, our idea really is how can we utilize artificial intelligence to combat climate change? Yeah. And this is the first graph sort of kicked off the complete idea in 2019. We really want to harness artificial intelligence for the good. What you can see here is the energy use of a Google server installation that was optimized with DeepMind's technology. You can see the energy savings here in green and the training cycles in blue. And from this you can see that already the initial optimization led to an improvement of 12% for energy use for cooling of the servers. Obviously, server cooling is an enormous problem for energy use overall. We're getting more and more servers, and these are emitting a lot. Yeah. You can see that over the course of a year, with roughly 18 million training cycles, you can optimize this to 30%. Now, the critical idea we had is if we do that for all of the economy, if we have these capabilities rolled out on a large scale, what can we actually do? And we think we can do a lot, and that's what the rest of the talk is going to be about. However, the question is, how can it be that artificial intelligence has such a direct impact on many areas of human life? We, in the end, have created a digital world via intelligent sensors, the Internet of Things, edge computing, cloud storage. So in the end, we've created a digital representation of the real, of the physical world in cyberspace. The next trick is now the cyberspace is not only a digital representation of the real world, but it can interact. And that gives us the opportunity to deploy state-of-the-art artificial intelligence to help optimize it. Here you can see the industrial realm as an example. So for instance, we can manage the inputs we need, maybe oil, gas, water, or energy, and essentially reduce costs using state-of-the-art digital technologies. This interplay between the cyber and the physical world we're calling cyber-physical systems. And these cyber-physical systems essentially were critical for the fourth industrial revolution. You know, the first three The fourth one is now what I've already mentioned, the cyber-physical system, the Internet of Things, etc. So all factories are getting optimized, they're getting integrated, and we can deploy artificial intelligence capabilities. The recommended reading here really is Klaus Schwab's The Fourth Industrial Revolution, if you're interested in this. All this is a blessing, especially for asset-heavy industries. Just imagine you're an industry with lifetimes of 50 or 60 years for your equipment. You now have to meet government targets for emissions reductions. You cannot really do much about the physical world, but you can use some digital technologies to optimize your factory, for instance. So that's where the idea came from. So we produced this compendium published by SpringerNature in a collaboration with Cambridge CARES, the Singapore outpost of the University of Cambridge. And you can see it's not an academic exercise. We're working with big corporates, with governments, with startups, and with NGOs to actually address this because it's just too complex. Good. Let's look at the results. The most interesting part, we're in an unpredictable world. That's one of the outcomes. We'll use photovoltaic electricity production as an example here. Here you can see a graph of the levelized cost of energy and its evolution of the last decade. You can see this is almost an exponential decrease. For the fun, you look at the forecast from 2010 of the International Energy Agency. You can see this is vastly underestimating the improvements of the levelized cost of energy, in fact, by 82%. So solar power is meanwhile the cheapest power. If we look at the range we need for fossil fuels to produce electricity, we are now well below that. The question is now, why did we underestimate this? We think from our book it becomes clear that we have a virtuous circle here that improves the overall production. Firstly, we are producing solar cells with a higher efficiency, reduced resource use, that results in reduced embedded carbon, and we can also increase the efficiency. And all this is due to production via Industry 4.0, advanced digital technologies, and AI. So these improved solar cells with higher efficiency and lower embedded carbon then result in more efficient electricity generation, extended life, and we're feeding lower carbon electricity back into the production process. So you have a very clear virtuous circle here, a feedback loop, and that's why we think this is pretty much unpredictable, and we often underestimate progress because we think in linear terms. So now, solar electricity is obviously very good because it's low carbon electricity. It doesn't use much resources, not as many resources as fossil generated power. But there are other problems. So in the early days, electricity provision was relatively simple. We have a centralized power plant. We generate electricity, give it into transmission distribution, and it ends up in residential or industrial areas. Now, with intermittent renewables, which you can see down on the left, this has gotten a lot more complex. Also, we have distributed energy provision because, for instance, in Europe and North America, more and more solar cells are installed. So we're getting a very complex system here. We have energy flow here in solid arrows, but we also have information flow back. So how can we manage this all? Obviously, a human cannot manage this. We need automation. As soon as we automate it with digital technologies, we can deploy AI capabilities. And here is a very good contribution from a company called Electricity that was just bought by a big player. Here you can see the city of Basel in my home country, Switzerland. And what they are doing with their software is they forecast electricity demand for essentially residential and commercial areas, and they forecast what will be produced with the solar power. And in the end, we are matching demand forecast with supply forecast. We continuously include weather forecasts and weather radar into this, so we can estimate the electricity backup that we require. And this is automated in a complete process. How does this help us? It helps us reduce the excess electricity that we have fed into the grid for a long time, just by optimization via artificial intelligence. So this saves us electricity and consequently emissions. If deployed on a large scale, this will really make a difference to electricity production and their emissions. What else can we do to manage this? We can use blockchain technology, for instance, smart contracts, to use it for energy trading. Very good contribution from the National University of Singapore here. You can see that decentralized energy trading is the biggest factor the most projects for blockchain technology. Yeah. Let's leave this for a bit. Also here, same contribution. We're looking at supply chains. Supply chains are getting more and more efficient due to digital optimization. So the logistics industry has been at the forefront of this. We have now RFID readers and everything. We have artificial intelligence that optimizes routes, etc., etc. So optimizing the way we get goods around obviously has a beneficial impact for the emissions from the logistics industry. But it's not just optimization of the status quo. We can also use it as a planning tool. And here you have a very good contribution from the ETH Zurich, especially the Singapore Center of the ETH. Here you can see a shot of the city of Singapore. Obviously very humid and hot city. Climate change will probably change that, make this humidity and heat even worse. So what is being done here by very smart architects and city planners is that they take climate scenarios, weather variation, change in the built environment, and they create models of the city and how different things will affect heat and outdoor thermal comfort in the city. Yeah. So they are using this to create scenarios for different cost benefits of interventions, energy consumption, and emissions impact. So here in an AI-supported digital models, service decision support tools. So they don't optimize the status quo, but they indeed work on the future. They help us plan. And if you're interested in this, please do check out Cooling Singapore. They are concerned with reducing heat islands in the city. Here in the red middle of Singapore, you can see downtown, the downtown area where the skyscrapers are. They obviously want to minimize additional heat in this area. So we can optimize the status quo using AI, but we can also use it as a planning tool. Here a bit from us. I slipped in some of our commercial work. You can here see the city of Pirmasens in Germany. You can see a level of detail 2 representation of the buildings. You can see the sewage network. And we are step by step building a digital twin to help optimize the city. We even include very detailed models of the building on a building information management level. And we are using solar radiation data to do exactly the same as we've seen before for the city of Basel, so that we can integrate all the energy systems, harness synergy between the different energy systems, and then help optimize the resource use and consequently the emissions of the city. Another very important topic is water supply. Obviously, with climate change, water supply will become more scarce. At the moment, global energy demand for water already equals Australia's energy demand. Reason for that is, and this is explained in a very good contribution by the company Siemens, it's a very energy intense project. Many regions in the world utilize desalination. That's an energy intense process. Then you have to go through the supply chain, pump the water to the consumers, domestic, industrial, and agricultural. You have to collect the wastewater and treat the wastewater. And you can see here, supply and desalination of water are the biggest areas. But in all of these areas that you can see here, we can optimize this using advanced digital technologies such as ML, DL. Siemens estimates that with existing technologies, we can reduce the energy use for water provision globally by 10 to 16%. With advanced technologies like artificial intelligence, we can multiply this. So we can drastically reduce the carbon footprint of water, and that will be an important topic, obviously, because we want to have water security for more and more people, and climate change will force us to utilize desalination more and more. Good. Let's talk about the overall impact. Most of you have seen this curve already. It's the so-called marginal abatement cost curve. On the y-axis, you see the abatement cost here in Europe per ton of CO2. And on the x-axis, you see the abatement potential in gigatons per year. In bold, you see the old values that were published in 2010. And in opaque, you see the values that we have now that we deploy intelligent technologies to it. I'll give you solar in blue in the middle here as an example. So we reduce the cost of solar provision, but due to grid management technologies that allow us to get more solar capabilities online, we also increase the abatement potential. Same goes for building. Also mentioned buildings already. We increase not only the potential, but also we reduce the cost of CO2 emission abatement from the built environment. And our estimation is that we have more than 50% to gain just deploying digital technologies right now. So we can already see that intelligent digital technologies can really make a difference to the climate change problematic. The economic impact, just a guesstimate I wrote here. This is a 2018 estimate, which estimates that by the end of this decade, contribution of AI to the global economy will be 7.4%. We already know that this is a vast underestimation right now, and we're in the year 2023. So just like with the emission impact, we think that the economic impact of artificial intelligence will be a multiple of this. And I wouldn't make any predictions at the moment, because also my predictions will be out of date by the end of the year, the latest. However, what we can do about economic forecasts, we can also include artificial intelligence capability into this forecast, and hence build different scenarios on the impact. Good. Scenario planning inside a digital twin. I already mentioned Singapore. Here, at the moment, I said we have actuation and data transfer between the physical world and a digital twin. The digital twin helps us to optimize the status quo. But now we can actually change the digital twin and provide different scenarios. So where should I build my new plant? Where should I build a park? Can I build a skyscraper here? So we can run all this in the digital twin before we build it in the real world and learn it the hard way. we can build different scenarios. Then we pick out the most advantageous and build the physical world according to that prediction. And we do that over and over again. So here you can see that artificial intelligence will help us build a better future just by planning. Also, if we use such an approach, we don't have the risks that are often associated with artificial intelligence. So we're not leaving the decisions to the artificial intelligence, but we're leaving the building of different scenarios to the artificial intelligence, while humans will pick out the most advantageous. Yeah, so we have a complete systems evolution that's supported by artificial intelligence. Conclusions. Cyber-physical systems, smart cities, Industry 4.0 allow us to understand system better. They help us to optimize the status quo, increase the lifetime of our infrastructure. The increased lifetime leads to lower life cycle costs and lower emissions. And digital twins, furthermore, allow us to plan the future using scenarios. And this helps us avoid lock-in situations, helps us avoid planning mistakes. Yeah. So the answer to the question I posed in the beginning, can CPS and AI contribute to decarbonization? It's absolutely a yes. We have, of course, in the book looked at the cost-benefit of emission saving and emissions generated, but it's definitely advantageous. So we always save more emissions than the digital technologies actually create. And AI is therefore, in our opinion, likely to facilitate the transition to a net zero economy and a circular society. Also, AI will help to improve economics forecasts via agent-based modeling. And that's it from me. I thank you very much for your attention, and I am looking forward to your questions.
Okay, thanks, Oliver. So, see any questions from the audience? So you can, just like previous session, you can feel free to put your question in the chat. And maybe one question from myself first. Mm-hmm. And as I know, the solution, the AI solutions you mentioned in the sharing is quite a big thing, I would say, because it involves like the city's planning, it involves about the energy. So in the implementation part, can you share some challenges when those city planning or those AI solutions need to be implemented?
Good. The implementation issues we will see in the foreseeable future. As it stands, these are more research projects than they're actually applications. So we are still at the very early stages. As you can see, most of these things are still academic projects, while we're already working with cities to do stuff like this. But we are really talking about a pilot stage. Definitely what will be one of the challenges is to get AI capabilities into software that's intuitive and can be used by people playing it. We cannot expect every city planner to be a computer programmer and AI expert, so we sort of have to provide these capabilities in software. This will definitely be one of the challenges we are facing. And then the other challenge we'll be facing, we are in the process of digitalizing many sectors of the economy. We have to make sure that we can include AI capabilities in parallel. So essentially the software we're installing at the moment, it has to be able to be connected to AI capabilities. But also, from our consulting work, we know that many companies work on this, on digitalization, and they are also obviously eyeing AI capabilities, and they make sure that these AI capabilities can be added.
But in future, do you think that, like, because I think there's include like we need to have some AI expert to work on it, and we need maybe the company or the government's involvement and also the AI capabilities. So in future, do you think like which part is the most important if we need to make it happen?
If we need to make it happen, definitely the development of AI and the responsible development of AI. Obviously, there are huge issues with, for instance, data privacy. Is AI aligned with humanity's goal, etc.? That's one thing, so we have to give it a bit ethical. I think there will definitely be a good job market for everyone who's programming in AI. I can definitely, that's one of the predictions I can make right here, right now. And the other thing is obviously, getting these AI solutions to the market. And again, I really think that getting them in a manner that you can use by everyone is very important. But you can already see it from GPT-4. It's very intuitive and most people can utilize it. It's going to be crucial that it's going to be implemented like this in planning software, in optimization or software that is used by corporates.
So we have some questions from the audience. One is, so what's AI's role in communications or marketing climate solution and policy like ChatGPT?
Good. That's a very good question. I haven't fed in climate change to ChatGPT, but I should have done that already. You're absolutely right on that. What I think these communication tools like ChatGPT, these language models, they should give a very balanced view of climate change. Yeah, they shouldn't be biased. Obviously, bias is also one of the big issues around climate change. And they should, clearly and simply communicate the climate change issues to people. In the end, obviously, we have to decarbonize the economy systematically, but also we as consumers have a role to play with adapting our consumption behavior. So I think language models like ChatGPT do play a role in this as well.
That's good. So another question from Alex. So the planning you previously or could be AI powered.
Yes, we see these capabilities coming online as we speak. However, it's not common practice right now. We're still using standard development tools, but as I already said, we have many universities working on it. We have many universities working, for instance, with cities on the planning. But again, we are early stages here. I would hope that soon we see more of these endeavors coming online, but we are still in the early stages.
Okay. So see if we have any other questions from the audience.
I can see.
I see Alex is typing.
Yeah.
It would to create and plan digital twins with the help of AI.
In the end, that's what we're doing. Yeah. So we don't build digital twins from scratch, but we, as I said, we are providing digital representations of cities, and then we try to optimize and integrate the energy systems. We will assist with the planning, but again, also this is work in progress. This is not completed yet, but we're working on it.
Okay. Then I think, yeah, it's great. I think that's all for this session. And thank you so much for your sharing. And it's I think it will be really great. Someday we can see it can be really implement AI and do the decarbonization.
Yeah. And if you ask me, we always underestimate when it comes to this. We'll see this sooner than we actually would guess now.
Yeah, that's true. Okay. Thank you
Fantastic.
so much.
Thank you.
Yeah.